Hey everyone, I've got a question for you. Is 2 to the 10th the same as 4 to the 5th? Yeah, you might be reaching for your calculator right now to figure out how much 2 to the 10th is and how much 4 to the 5th is, but really we don't need to, because we know a law of exponents that will help us out here. So I recognize that 4 is the same thing as 2 squared. So I'm going to substitute in 2 squared in for 4. So 2 squared is the same thing as 4. I haven't changed the value of anything. I've just changed how it looks. And now notice, when I have an exponent raised to an exponent, I multiply them together, and most definitely 2 to the 10th is the same thing as 2 to the 10th. We're going to use this idea of substituting base with an exponent in for a number to help us solve exponential equations, equations that have an x in the exponent. So our first option of solving for x when the x is in the exponent is if you can get the bases to be the same, then the exponents are going to be the same or equal to each other. Looking at this first example, 5 to the 6x equals 25 to the x plus 2. Now many people fall into the trap here of saying, oh, let me just square the left side of this. But no. Because remember, with our power to power rule, the only thing that would get squared here is the 6x. The squared doesn't touch the base. So it would remain 5 to the 12x. So instead of squaring the left side, we can substitute in a value for 25. You've already recognized that 5 squared is 25. So I'm going to rewrite 25 as 5 squared to the x plus 2 is equal to 5 to the 6x. And now that the bases are the same, the exponents are going to be the same. So we're going to have 6x is equal to 2 times x plus 2. And then we get into a little rinky-dink algebra here. Doing the distributive property makes 2x plus 4. Solving for x, I'm going to move my 2x over to the left. And I get 4x equals 4, and x supposedly equals 1. Now remember, nice thing about equations is we can always check to make sure that's right. So is 5 to the 6 times 1 equal to 25 to the 1 plus 2? And abracadabra, there you go, 15,625 is what 5 to the 6th and 25 to the 3rd is equal to. So our x equals 1 value was correct. It does check out. Next equation, 8 to the x minus 1 equals 2 to the x plus 5. So looking at that 2 there, I hopefully can change 8 into 2 to the something. Well, 8 would be the same thing as 2 to the 3rd. So let's substitute 2 to the 3rd in for 8. Haven't changed its value, we've just changed how it looks. And now that the two bases are both 2's, now we can just work with our exponents. 3 times x minus 1 is equal to x plus 5. And then doing our algebra, minusing x from both sides, adding 3 to both sides, we're going to get 2x equals 8. Which means x equals 4. So when we plug that back in, 8 to the 4 minus 1, or 8 to the 3rd, should equal 2 to the 9th. And there you go, 8 to the 3rd and 2 to the 9th, both equal 512. Our next equation, 9 to the x plus 1 equals 27 to the x. Now notice, I don't know off the top of my head, 27 is the same thing as 9 to the what? But we can actually break both of these bases down into a smaller base. 9 is the same thing as 3 squared, so I'm going to substitute 3 squared in for 9, and 27 happens to be the same thing as 3 to the 3rd. So I'll substitute 3 to the third in for x. Now my bases are both 3's, and now my equation that I can work with is right here. 2 times x plus 1 is equal to 3x. And distributing will make 2x plus 2 equals 3x. Minusing 2x from both sides means that x is equal to 2. And we could plug that back in and check it if we wanted. So 9 to the third should be the same thing as 27 squared. Last one. Uh-oh, we've got a fraction, 1/4. And a 16 on the right. Don't get concerned with the fraction. Let's get rid of the fraction. 1/4 is the same as 4 to the -1 using our negative exponent rule. So I'm going to substitute that for 1/4. And then we all know that 16 is the same thing as 4 squared. And now I've got both bases to be 4. So here's my equation I'm going to solve. -1 times x minus 1 equals 2. Distributing will make -x plus 1. Minusing 1 from both sides will make -x equals 1, which means positive x is equal to -1. And just to prove to you that 1/4 to the -1 minus 1 exponent does equal 16, there it is.